Okay, so first we're going to sketch the problem. So there's a boy that throws his book to his friend that's 20 meters apart. So now the data is gravity, that it's equal to minus 9.8 meters over second square. And then the distance, which is 20 meters, that's y. And the initial velocity, which is 0. The first thing we had to do was find the position function of the book. So in physics, the equation is y equals y0 plus initial velocity times time, which is going to be 0, plus gravity times time to the 2 over 2. And in math, it's space-time equals space 0 plus initial velocity times time plus gravity times time to the square over 2. And that will give us space of time equals 20 minus 4.9 times t to the 2. So in letter B, we had to find the velocity function by using the limit definition of derivatives. And this is the function, and then we just substitute the values that we have, well, the variables, which are t, and I substituted from x. So it's s of t equals limit as h approaches 0, s times t plus h minus st over h. And now we substitute the values here. Limit as h approaches 0, it's 20 minus 4.9 times t plus h to the square minus 20 minus 4.9 t to the square over h. And if we substitute, it will give us 0 over 0. So the next step was to get rid of the square. So here's the result. And then we have to get rid of the parentheses. And here's, we get rid of the parentheses. And then we just eliminate 20 with minus 20. And minus 4.9 plus 4.9. And we get this minus 9.8 th minus 4.9 h to the square over h. And then we factorize an h, and it will give us minus 9.8 t minus 4.9 h. And if we substitute the value of h from 0, it will give us minus 9.8 t. So our velocity function will be b of x minus 9.8 times t.
So letter C is telling us to find acceleration function by using differentiation rules. And one of them is the power rule, that its formula is this. It's x to the n power to the 1 power equals n times x to the n minus 1 power. So here we're going to substitute n equals to 1 because that's exponent. And here we have the t is to the 1. And x is going to be it's going to be our variable, and it's going to be t. So here we substitute t to the 1 to all these to the 1 equals 1 times t, and 1 to the 1 minus 1 power. And now here it's going to be 1 minus 1 equals to 0, and everything at the 0 power, it's going to be 1. So here our result is 1 times 1, and it's going to be 1. So t to the 1 power, it's going to be 1. Use a multiplying with constant rule, that its formula is b times x times t times 1 to the 1 and to the 1 power. And here we have the b times x equals minus 9.8 t. So here we have the minus 1, 9.8 plus 1, that is the one that we got here, 1. It's equal to 1. Time equals minus 9.8.
Okay, so now we have to calculate the velocity of the book after 1.1 seconds. The equation we're going to use is gravity. It's equal to final velocity minus initial velocity over time. And then we just pass the time to the other side, multiplying gravity. So it's gravity times time. It's equal to final velocity minus initial velocity. So we just pass the initial velocity to the other side, which is adding the gravity and the time. So now it's gravity times time plus initial velocity, it's equal to final velocity. Now we just substitute the letters for the numbers, and then we multiply those, and then it's equal to final velocity, it's equal to minus 10.78 meters over second.
So for letter E, we need to find the velocity of the book when Mike catches it 1 meter from the ground. So our data is y equals 90 meters because it catches it from 1 meter from the ground. And our gravity, well, it's minus 9.8 meters per second squared. We don't know time, and initial velocity equals 0, and we need to find velocity final. So our equation is going to be y equal initial velocity times time plus gravity times time to the square over 2, okay? So we here cancel velocity initial because it's 0, so it's 0. And isolate the time, and we substitute the values, something, and we got 12.02 seconds. And now that we have time, we're going to find velocity final with this equation. So we isolate velocity final, we substitute the values, and
so now we have the data, and first we had to get the final velocity, which is this, and then we use this equation and then for the initial velocity, and it's equal to 17.15 meters over second.